In this section, we're going to talk about dividing polynomial functions. And before we get into that, I want to explain a little bit about why we need to learn how to divide polynomials. And so, if P and D are polynomials with D not equal to 0, then there are unique polynomials Q and R, where R is either degree 0 or degree less than D, such that P of x divided by D of x is equal to Q plus R over D, or we can write it as P of x equals D times Q plus R. And again, the reason we want to be able to divide polynomial functions, here are some terms for all of these letters. Again, you don't really need to know these as much as needing to know this. But if you think back to graphing our polynomial functions, our basic graphs, what we said were, in order to get them, we would take our polynomial, factor it down, and then use the factors to find the zeros or the intercepts, and use the end behavior to sketch the graph. Well, some of our polynomial functions don't factor. And so the only way we're going to be able to find the zeros is if we can divide it out and rewrite the polynomial in terms of products of things that don't have remainders. And again, sometimes we can't factor to do that. We're going to need long division or synthetic division, which are the two types of division we're going to talk about in this video. Okay? So for long division of polynomials, I usually start by reminding you of how to divide rational expressions. Many people didn't learn long division of numbers the same way. And so I'm going to show a specific way of doing this that is going to help with finding the division of a polynomial function. Okay? So if I think of 157 divided by 23, again, many people learned how to divide this differently. But if I'm going to think of it in terms of how I'm going to do the polynomial functions, I'm going to start by thinking 157 is my dividend, so it's going to go inside my box, and 23 goes on the outside. It's my divisor, what I'm dividing by. Okay? And to do this division, I want to see how many times 23 is going to go into each component of the number. Okay? So if I look at 23 into 1, obviously 23 doesn't go into 1 anytime, so I'm going to move 1. How many times will 23 go into 15? Again, it doesn't, so I go 23 into 157. Now I know it's going to go in there some number of times, but I don't know how many. And so instead of looking at the whole number, I'm just going to look at the first digit into the first part of the number. So if I look at the 2, I want to know how many times it's going to go into 15. And we can think, well, it's about 7. Okay? I'm probably going to need a little less because I'm not just looking at 2. I'm looking at 23. So we're going to try 6. So 6 times 3 is 18. Carry my 1. 6 times 2 is 12. Plus 1 is 13. Okay? I'm going to go ahead and subtract. So once I've multiplied through, I'm going to subtract from the dividend. So we'll get a 9. A 1 and 0. We can see 23 has a remainder of 19. This is less than the term I had out here. So in this case, I'm done. I can't go further. Now again, when we looked at real numbers, we added zeros because we wanted to find the rational number. But for this, I'm going to stop here. And so if we think about what we said over here, this says that 157 divided by 23 is going to equal my quotient, which in this case is 6, plus my remainder over my divisor. Okay. Or I can write this as 157 is going to equal 6 times 23 plus 19. Okay. And we can check that both of these things are equivalent. Okay. Now with polynomials, the idea is exactly the same. The difference is that instead of having just the numbers to work with, I now have terms. So there are pluses and minus signs that are going to show up in my divisor as well as my dividend. And so things, like I said, work similarly, but there are some differences that we're going to see. Okay? So here let's consider the polynomial x cubed minus x squared minus 2x plus 6 divided by x minus 2. Okay? I'm going to start by setting this up the same way. My dividend is going to go inside my box, so x cubed minus x squared minus 2x plus 6. And outside of that is going to be my x minus 2. Okay? Just like over here, I'm going to look at the first part of my divisor and find out how many times it'll go into the first part of my dividend. So in this case, x will go into x cubed, x squared times. And just like over here, I'm going to multiply that all the way through. So I'm not just multiplying by the 2 there. Here, I'm not just multiplying by the x. So the x squared, I'm going to multiply by the entire polynomial. I'll get x cubed minus a 2x squared. When I subtract that, negative x squared plus 2x squared looks like an x squared minus 2x plus 6. So notice I bring down everything else. Okay. Now we're going to check just like we did there. So remember here we were looking that this number was smaller than this number. For polynomials, we want this degree to be smaller than this degree. If it's not, I'm going to keep going. So in this case, because this is an x squared and this is an x, same thing. I want to figure out how many times this number will go into the x squared term. Okay. And so we can see we're going to need a positive x to get an x squared there. Same thing, I'm going to multiply it all the way through. And then subtract. So my x squareds will cancel. Negative 2x plus 2x, those cancel out. So I'm just left with 6. Okay. Just like our numbers, we can rewrite this in terms of either method. I can either write it as the fraction or I can write it as an equation. So as a fraction, this is saying that x cubed minus x squared minus 2x plus 6 divided by x minus 2 is going to equal my quotient, x squared plus x, plus my remainder over my divisor. Okay. Or I can say that x cubed minus x squared minus 2x plus 6 is going to equal x squared plus x times x minus 2 plus 6. And again, we can multiply these out or go ahead and rewrite this to see that these are equivalent. So let's look at a couple more examples of long division. So in this case, we're looking at 4x cubed plus 2x squared minus 2x minus 3 divided by 2x plus 1. Here we're going to do the same thing. The difference is my divisor now has a coefficient in front of that x. Okay. So again, I'll start by setting it up. So we're going to say the 4x cubed plus 2x squared minus 2x minus 3. We're going to divide that by a 2x plus 1. Okay. So, same thing, I want to figure out how many times 2x will go into 4x cubed. So in this case, I'm going to need 2 times my x squared to get 4x cubed. Multiplying through, and then subtracting. So notice here when I subtract, that first piece goes away, and so I'm going to be left with a negative 2x minus 3. Okay. Again, notice here, the degree here is the same as the degree there, so I'm not done. I need to go one step further. I need something times 2x to equal a negative 2x. So here I need to multiply by a minus 1. And that will give me a negative 2x minus 1. When we go to subtract, The two x's will cancel out. We'll get a negative 3 minus a negative 1, which looks like a negative 2. Okay. Again, here my degree is 0, my degree here is 1, so now I'm done. So my 4x cubed plus 2x squared minus 2x minus 3 over 2x plus 1 is going to equal 2x squared minus 1 minus 2 over 2x plus 1. Okay, and again, you can write the other format as well, but there is my division. In this example over here, again, I'm looking at a divisor that has a leading coefficient bigger than 1, but also my divisor is now a quadratic and not a linear term. The other thing to notice is if I look at my dividend, my terms there don't encompass all of the degrees down to 0 in my polynomial. Over there, if I look, we can see it started as a third power, but there was a squared, a linear, and a 0 power term. Here I'm starting at the fifth, but I don't have the third or second or first power terms. Okay? So in an example like this, the first thing we're going to do is we're going to, again, write out our polynomial, but now I have to take into account that I am missing some of the terms of that polynomial. And so to do that, I'm just going to plug in zeros as the coefficients for those, because 0x cubed is the same as 0, so I haven't changed my polynomial. Okay. From there, we're going to do the same thing. So I'm again looking at this first term, figuring out what I need to multiply by to get that first term in there. Now this is where it gets tricky because my coefficient here is bigger than my coefficient here, which means instead of just multiplying by some factor, I actually have to do some division as well. And so here we can see if I take 4x squared and multiply by 1/2 x cubed, I'm going to get my 2x to the fifth. Okay. So multiplying all the way through gives me a 2x to the fifth minus a 3x to the fourth plus 4x cubed. Again, we'll subtract. So negative 7 minus a negative 3 looks like negative 4x to the fourth minus a 4x cubed plus our 0x squared, 0x minus 13. Okay. Same thing, degree here is bigger than degree here, so what times 4x squared will give me a negative 4x to the fourth? Okay, I'm going to need a negative, and the 4's already match up, so I just need the x squared. Same thing, we'll multiply all the way through. So negative 4x to the fourth plus, so negative and negative, 6x cubed minus 8x squared. Okay. Again, here our x to the fourths will cancel out. We get a negative 4x cubed minus the 6x cubed. Looks like a negative 10x cubed. 0 minus the negative 8, so plus 8x squared, plus our 0x minus 13. Okay. Again, from there, what times the 4x squared will give us the 10x cubed? Okay. So here, if we look, multiplying by 5/2, we get some fractions in here. Again, I need that to be negative so that my signs will match up. And then x squared to x cubed means I need another x in there. Okay. So multiplying through, we'll get a negative 10x cubed. Multiplying 5/2 by 6 looks like a plus 15x squared. The 5/2 times the 8 looks like a minus 20x. we'll go ahead and subtract. The x cubed terms go away. 8 minus the 15 looks like a negative 7x squared plus a 20x minus 13. Okay. And lastly, again, degree here is the same as the degree here, so I have one more step to go. Okay, so we need 4 to go into 7. Again, we're going to need a fraction there. So if I multiply by 7/4, make that negative to match the signs. Multiplying through, negative 7/4 times the negative 4x, or positive 4x squared, gives me a negative 7x squared. Negative 7/4 times my negative 6 will give me a 21/2. And then for my constant term, 8 times the 7/4 looks like a negative 14. Got to be a little careful here because, again, we've got the fraction in there that we didn't have. So when I'm subtracting, obviously my 7's go away. The 20 minus the 21, I'm going to need a common denominator. So you can think 40 over 2 minus the 21 over 2, which looks like 19 halves x. And then the negative 13 minus the negative 14 gives us a plus 1. So here, when we do our division, the 2x to the 5th minus 7x to the 4th minus 13 over the 4x squared minus 6x plus 8 is going to look like 1/2 x cubed minus x squared minus 5/2 x minus 7 over 4. And then for our remainder, you have to be a little careful how we write that remainder. I'm actually going to bring this down a little bit so it doesn't get into my division over there. For my remainder, remember this is going over my divisor, but we don't want complex fractions in our answer. So I'm going to rewrite this as 19x plus 2 over 2. So we'll get 19x plus 2. We'll bring the 2 down to the bottom and put in our divisor. Okay. So there would be our solution for that polynomial. Okay. Now, most of the polynomials that you're going to be asked to divide are not going to be quite this expanded, but you should still know how to do this in case you have to get one of these larger polynomials down to some smaller ones. Okay, so this is our long division. Now let's take a look at synthetic division. So before we look at some examples of synthetic division, I just want to briefly talk about the differences between that and long division. Okay, so first, synthetic division will give the exact same results that you will get from long division. So again, I'm just basically dividing polynomials. I'll be able to find the quotient and the remainder using either method. It's about the same amount of work, it's just a lot less space, and I'll show you that in a minute. So this is useful if you've got to do a lot of synthetic division or a lot of divisions. It's useful to use the synthetic because it's going to take up a lot less room than the long division is. Okay. The one setback between synthetic and long division is synthetic division can only be used for linear divisors. Okay, so things like x plus 4, 2x minus 3. I can't have squares or cubes like I can with the long division. So that's almost a setback, but for most of what we're going to be doing, that's actually a benefit, because again, it'll take up a little less room. And as I just said, it's better for finding roots, because if I'm dividing out by a linear factor, then I can determine whether or not that factor is a root of the polynomial, okay, which is what we're going to be looking for. Okay? So the setup for our synthetic division is a little bit different than what we use for long division. And so instead of kind of the inverted box, we have one that's kind of upside down, We're going to put our coefficients of the dividend across the top. We're going to find the 0 of the divisor, and that's going to go on the outside. And then we're going to use this space in here to actually do our work. So a lot like when we're subtracting the polynomials, this is where we're going to subtract the work, or add, I should say. And then at the bottom, once we're done the synthetic division, this is where we're going to find our quotient. We'll get all the coefficients for that quotient there, and then the last spot will be our remainder. Okay? Now, one of the reasons this method is a little nicer than the other is because, notice here I say the coefficients of the dividend and the coefficients of the quotient. We're not actually using the entire polynomial. We're just looking at the numbers. So for those of you who don't like the variables in there, this kind of removes that. Okay? So let's look at an example. Let's say we have x squared minus 5x plus 4, and we want to divide out by x minus 1. Now again, notice here I've got a linear divisor, which means I can use my synthetic division. Okay? And so for my setup here, I'm going to set up my box. Okay? I'm going to pull off the coefficients here. Again, if there are missing terms, I want to make sure I add zeros in there, just like we did with the long division. Okay? And then for my divisor, I'm going to find its 0. Okay? Again, all that means is I want to say x minus 1 equals 0, and I'm going to solve for x. So in this case, I'm looking at a 1. Okay? Now, to do the synthetic division, we're going to start by just bringing down that first term. Okay? So my first term comes down, and then I'm going to multiply by the divisor. So 1 times 1, that's going to go over here. Okay? So in purple here, I'm going to write out the step. I took the 1 times the 1 to get that term. Okay? From there, I'm going to add to get the remainder piece. Okay? So this came from the negative 5 plus 1, and that gave me the negative 4. Okay? Again, same thing. I'm going to multiply by the divisor. So here we did negative 4 times 1 to get that term. And lastly, again, I'm just going to add to get the 0. So here again, this was 4 minus 4 to get that term. Okay. Now, just like before, what this is telling us is it gives us our quotient and remainder. But more importantly, if that last term is a 0, that tells me something special about that division. Okay. So in this case, my quotient, again, this is the coefficients of my quotient. These are always going to have degree 1 less than the polynomial I started with, because I'm dividing out by a linear factor. So if I start with a square and divide out by a factor of 1, it's going to go down to a factor of 1. If I start with a 4th degree and divide out by a factor of 1, it's going to go down to a 3rd degree. So here, my quotient is going to be x minus 4. And my remainder just happens to be 0. Okay? And you don't need to write this piece, so I can just say this is x minus 4. Okay? And we'll talk a little bit more about that nice 0 in a little bit. Okay? So let's look at another example. Let's say I've got x cubed minus 8x plus 2. I want to divide out by x plus 3. So again here, I need to start by setting up my synthetic division. Again, I need to start by making sure that I am looking at something linear, which in this case I am. So 1, I don't have a squared term. There's my linear term. There's my constant. Again, to get my divisor, x plus 3 equals 0. So x will equal negative 3. Okay? So again, I'm going to start by bringing down that first term. I'll multiply here, and then add. Okay. Same thing, multiply here, adding these terms. One last time, I'll multiply here, and add. Okay. So for this one, I don't quite get a remainder of 0, but I can still pull off my quotient and my remainder. So again, in this case, this last term is my remainder. This piece is my quotient. So my x cubed minus 8x plus 2 divided by x plus 3 is going to equal x squared minus 3x plus 1 minus 1 over x plus 3. Okay. So there's some examples of our synthetic division. Okay. And again, the nice thing about this is it does not matter how big that polynomial is on top. I can always add the zeros in. As long as it's a linear divisor on the bottom, I can use the synthetic division. And as you can see, it takes up a lot less space than your long division. The fractions here are also going to be a little nicer to work with because you don't have the variables in the way.